Hello, everyone. Again, I want to welcome you to today's webinar. It's titled Quality Assurance, Evaluating Ceramic Tile Installations. I'm Jim Olson with the National Tile Contractors Association, and I want to welcome you and thank you for taking time out of your busy schedule to attend today's webinar, which is sponsored by Custom Building Products. Before I introduce today's speaker, I do want to remind you of a little bit of business to take care of. During the webinar, you'll be muted. Please use the questions area on your computer and type in your question, and we'll answer those questions at the end of the presentation. If the audio on your computer is poor, either turn up the volume or call the number on the invite to this webinar and listen on your phone. All NTCA webinars are available to watch at any time on the NTCA YouTube channel shortly after the webinars are presented. This will give you easy access to watch and or share all current and past programs at your convenience. All right, I'm happy to introduce today's speaker, Mike Little. He's a 50-year veteran of the ceramic tile industry. He has held management positions in both sales and operations during his career in the ceramic tile industry. In addition, he has worked for both manufacturers and distributors in various capacities. For the last 16 years, Mike has worked as an architectural consultant with Custom Building Products. Mike is a member of the Construction Specification Institute and is a construction documents technologist. He belongs to the Ceramic Tile Institute and is a certified tile consultant. Mike is also a professional affiliate with the Dallas chapter of American Institute of Architects. He also is an industry partner with the American Society of Interior Designers, and he's also earned the designation of Certified Concrete Slab Moisture Testing Technician. Wow, that's a mouthful right there, from the International Concrete Repair Institute. With a focus on sustainability, Mike is a LEED LEED AP and is a voting member of the American Society for Testing and Material Committee E60 Sustainability. In his current capacity, Mike has provided hundreds of hours of continuing education learning units to architects and designers in Texas and the surrounding states regarding all aspects of the installation of ceramic, natural stone, glass, and metal tiles. Hey, Mike, very interested. Can't wait to hear your presentation here. Welcome and thank you.
Thank you, Jim. Appreciate it. Well, as Jim indicated, what we're going to be talking about today are how we go about evaluating ceramic tile installations. And if I can get my screen to move, there we go. The learning objectives will include making sure that the installations are completed according to industry standards, not someone's idea of what should or shouldn't be happening. This program will also discuss how to recognize proper product selection and how to go about making that. And in that instance, we're talking about not just the tile, but the installation products as well. Participants will learn when to recognize situations that require special considerations. And one of the things that comes to mind here for me is the technology of new glazed porcelain tile panels and how they require different methodologies and equipment. And finally, we hope by the end of this, everyone will have a better understanding of thin-set mortar selection and installation techniques. The first mention of quality that we see on projects usually occurs in the specifications. And in the CSI specification section 014,000, it talks about quality inspections and tests performed by various authorities. However, what it doesn't address are contract enforcement activities performed by the architect or the construction manager. And in that regard, that's where we're going to spend a lot of our time. What should those folks be looking for as they're evaluating these installations? And when we talk about evaluating these installations, we have to have standards and guidelines to assess them with. And as we add new technology to our business, it requires new standards and new methodologies. So here are the three probably most prominent publications that we'll be referring to. The first one is ANSI A108, A118, and A136.1. A108 is the specification for the installation of ceramic tile. A118 is the specification for the materials used in those installations. And A136.1 is the specification specifically for adhesives or mastics for use in ceramic tile installations. ANSI 137.1 is the specification for ceramic tile, has to do with physical properties and grading procedures of tile, what you can expect from the tile itself. And then finally, the Tile Council of North America's handbook will come in because it's regarded as the best industry practices. And when we talk about new technologies and how things have changed over the years, I'll just give you this little tidbit to start with. In 2003, the Tile Council of North America handbook was a total of 45 pages. In 2023, just 20 years later, it's now up to 441. So when people talk about changes, they're not just talking. It has really happened, and happened with a bonus in our business. Now, as we go through these specifications, I want you to understand that most of these specifications are objective, meaning they can be measured in some form or another. However, there are a couple that are kind of subjective, and we'll talk about that as we get to them. But where we're going to start is before the installation actually begins. Using these standards and guidelines, there are things that we should be looking for when we talk about what is in a ceramic tile installation. The first thing I want to talk about is perhaps the most important to the designer and the architect. And the reason for that is this is one of those areas that can lead to liability. And I'm talking about slip resistance and slip fall accidents. ANSI A326.3 was introduced in February of last year, and it modifies some of the things that we use to determine what is slip resistance. And I want to emphasize here that A326.3 is talking about level surfaces only. And it will help the designer tremendously because the specifier is the one who determines materials appropriate for a particular project. And he has to take into account the type of use, where it's going to be used, the type of traffic that it's going to get, the expected contaminants, the expected maintenance program, the expected wear of that product, and the manufacturer's guidelines and recommendations. That's a lot to take in. Now, A326.3 was refined recently to help the specifier kind of guide his material selections as it relates to the flooring material itself. And it's going to allow the manufacturer to communicate product use to that designer. And the way they're going to do that is by classifying it in one of 5 classifications. It's either going to be interior dry, interior wet, wet plus, exterior wet, or oils and greases. Now, the criteria for those classifications, as I've put up on the screen, is a little bit different. Interior dry requires a dynamic coefficient of friction, or DCOF, of 0.42 dry per section 10.1. The classification for interior wet requires a 0.42 greater DCOF according to section 9.1. Now those look identical, but what's different is the testing method. In testing method 10.1 for dry, it's tested dry. Still has to achieve that 0.42, but it's dry. In the wet test, they actually use a soapy water medium as part of the test, and it still has to achieve that 0.42 DCOF even under those conditions. So again, it's a very specific installation methodology. Interior wet plus, exterior wet, and oils and greases will now be manufacturer declared. In other words, quite frankly, some of the liability has been transferred back to the manufacturer. The manufacturer is now going to determine which products he deems to be acceptable in those particular areas. And in order to make that a little bit easier to understand, they've given us of the different examples of work areas in those different 5 classifications. So for example, in an interior dry situation, they're talking about indoor shopping malls, hotel lobbies, office buildings, and showrooms. In the interior wet, they're talking about, for example, entry foyers, public restrooms, grocery stores, and the front of house dining areas. The interior wet plus would include showers, interior pools, locker rooms, and covered exterior areas. The exteriors would include pool decks, patios, walkways, and sidewalks. And finally, the oil and grease would be areas that might be exposed to automotive fluids, like a car workshop, the back of the house fast food restaurants, which we know accumulate a lot of grease, and food prep areas that have grills or fryers that may splatter onto the floor, giving it that kind of consistency. So those are examples of work areas where those different classifications might come into play. And by the way, that A326.3 standard applies to all hard surface materials, which includes vinyl and VCT as well. So it's an encompassing standard across a wide range of products. In 2020, IAPMO, the International Association of Plumbing and Mechanical Officials, adopted a new provision in the swimming pool, spa, and hot tub code. And in it, it requires a specific DCOF for decks, ramps, coping, and similar situations. And this is a wet DCOF. And the way they determine that dynamic coefficient of friction is by using this equation. Now, I'll be real honest with you here. I don't know what this means, but we have a lot of very intelligent, sharp people in our technical services department. And they were able to give me a cheat sheet where we can put in the angle of slope in degrees, and it will calculate the new DCOF required. So just as an example, a 1 in 20 slope would equate to a 2.86 degree angle. If you plug in 2.86 degrees into that equation, it will give you a DCOF of 0.48003. So in order to have a coefficient of friction for a ramp of that angle, you'd have to have a product that met that 0.48. If you plug in a 1 in 12 ramp, that degree is 8.33%. And that DCOF comes out to 0.60353, or roughly a 0.60 DCOF. So it's very variable depending on what kind of an angle you're trying to use. Now, right now, this only applies to swimming pools, spas, and hot tubs. But one of the things that I've noticed over the years is that when somebody comes up with an objective way to quantify something, in this case, a DCOF, a lot of the other standards and codes adopt that very quickly. And it wouldn't surprise me to see something like this adopted in the IBC and RBC codes, and maybe even the LEED or something like that very, very quickly, because it does give you a specific target to aim for. Job site and substrate considerations are are paramount on our mind before we start a project. And the first thing we have to determine is what is a proper substrate for a tile installation. Well, for many years, that included concrete or masonry or cementitious backer board. But remember, I talked about new technologies develops new methodologies and new standards. Well, we now have the ability by using a primer to go over existing tile work without the mess of sanding or abrading the surface of the existing tile and the dust that produces. We can go over epoxy coatings. We can go over exterior grade plywood and OSB if it's on an interior. We can go over vinyl and VCT with ceramic tile. We can go over laminates, fiberglass panels, and we can even go over cleaned rust-free steel if we use a primer as the bonding agent to those materials. So it's, we've got a lot of options available to us that we didn't have in the past. Just one more example of how the technology is helping us change our methodologies. ANSI A108.01 general requirements is for subsurfaces and preparations by the other trades. And I'm going to point out two here. 2.2, floor drains must comply with ANSI A112.21 and have proper slope, which means if someone other than the tile installer is installing the drain, it's expected to have the proper slope. Generally, that's considered 1-in-4 slope to the drain. And obviously, the purpose of that is to make sure that we evacuate all of the moisture and therefore the slip fall incidents out of that drain system. 2.3 deals with deflection, and it just simply states that the deflection must conform to RBC and IBC building codes. But again, the tile installer does not have any input on deflection. He has to assume that the deflection meets the requirements of the project that he's looking at, including the installed weight of the installation, and then he installs it. So if there's a problem with the flooring because there's excess deflection, that's not on the installer. That goes back to the designer. That's an improper design. Same thing with the floor drains. If it's installed by a plumber, it has to meet the ANSI specs and have the proper slopes. Those are not requirements on the tile installer. If the tile installer does install the floor drain, then obviously it's his responsibility to make sure he's complying with all of that. ANSI A108.02 general requirements concern materials, environmental, and workmanship. And 4.1.1 talks about what the surface should be. And it should be structurally sound, clean, dry, free of oily or waxy films and all foreign matter. Concrete shall be free of form oil, curing compounds, latents, and cracks. That's the requirement. 4.1.4.3.1 and 2 have to do with flatness requirements for both walls and floors. And we'll get to those in a minute. Here's something that has to do with that free of form oils or curing compounds. When you go on a job site and you see the concrete substrate with a patina or a shine, if you will, that should send up a red flag because it usually indicates one of two conditions. It usually indicates that there's a curing compound that was used on that concrete. Now, we like curing compounds in Division 3 because it slows down the hydration process of the concrete, which makes that concrete much more durable and harder in the end result. But if we're putting a curing compound on in Division 3, then we have to remove it in Division 9 before we can tile it. And that requires mechanically abrading it. The other condition that can cause that kind of a look to a substrate, and I see it quite a bit here in Texas, is when the slab has been over troweled. In other words, in an attempt to make it nice and flat, they just keep troweling and troweling and troweling. And what they're doing when they do that is that they're closing those pores on the concrete. And it's giving us no way to adhere our mortar to that substrate. And in that case, again, what we'd have to do is mechanically abrade that surface to get down to fresh concrete that has open pores that allows us to bond successfully to that material. If you ignore both of those situations, you can get what the photograph on the right is demonstrating. And that's where the mortar that we used adhered brilliantly to the back of the tile, but unfortunately never adhered whatsoever to the substrate because of that, either that curing compound or that over-troweled situation. So again, something to look for in terms of substrate preparation. ANSI 108.02 section 4.1 also talks about installation work shall not proceed until satisfactory conditions are provided. That can also be restated as if tile work begins, the conditions are accepted. And that's an important distinction there. If we have problems with the installation being done because it's not flat enough or the surface isn't the right surface, we're looking for a concrete surface prep of 3. If it's flatter than that, any number of things can cause us to say, hey, wait a minute, I've got a problem here. Now, that also specifies that all materials within the tile assembly will be at a certain temperature and be maintained before, during, and after installation. Now, the manufacturers will give you suggestions on how long that is and what temperature that is, and it's going to vary by product. But probably the product that is most sensitive to temperature in our business is our epoxy mortars and grouts. And they have the tightest window of temperatures because they really don't react well in the cold. They get too hard to move and they really set up too fast in the heat. So it's a very much narrower temperature range that they can be successfully installed with. Always check with the manufacturer before you do installations in very cold or very hot temperatures, because it can make a difference. Environmental conditions and protection. This is talking about the spaces where the tile's going on should be protected, shouldn't be walked on, and traffic should be kept off of it for at least 72 hours. And in fact, the National Tile Contractors Reference Manual, wonderful, wonderful reference point for particularly for problem solution, even has a draft of a letter to the owner or general contractor informing them that the newly installed tile, stone, or glass tile floor finish assemblies should be protected at the referenced project. So again, talking about proper protection and making sure that nothing happens to that installation once it's installed. One of the problems that we see fairly frequently is drywall dust in newly grouted tile installations. And as everybody can attest to, that is a very difficult situation to correct. It's a much easier situation to prevent, and that's what this section of these standards are all about, is preventing, those kinds of situations. So the fact that tile and other flooring materials are finished materials means that the substrate is going to have a huge impact on what the finished product looks like. Now, I think we've all been dealing with large format tiles long enough to know that the flatness requirements for both walls and floors changed to a much smaller variation. That variation is 1/8 of an inch in 10 feet and no more than 1/16 of an inch in 2 feet from the required plane. We've had that for a long time now, and I think everybody's pretty well used to that. But what is floor flatness and who's responsible? And here's where it gets a little tricky. If you ask a concrete subcontractor what floor flatness is, he's going to talk in terms of an FF number. But if you ask a tile subcontractor, he's going to talk about variations based on a straight edge level. And there is a huge difference. FF and FL numbers were developed in the 80s by the American Concrete Institute as a way to provide a measurable way to determine the flatness and the levelness of the floor. Now, in the tile side of things, we're not all that interested in level usually. In fact, there are some situations where we don't want it to be level, sloping to a drain, a balcony on an exterior. We want that to slope well away from the building to let the water that accumulates, flush off and not be pulled up next to the building and doing some damage. So that FL is not as big a concern, but the FF does have an impact on it. And all of these were designed to help facilitate bid work during the design process. And the methods to evaluate and the range is a lot different than between these two methodologies. There's a device called the dipstick that's very, very popular for measuring concrete flatness. They get much more sophisticated, as the photograph on the top left indicates, and it measures it down to a maximum gap in milliliters based on FF numbers or floor flatness numbers. The straight edge, he's looking for how much of a variation do I have in that slab? Half an inch, quarter of an inch, 3/16, or super fine, which in this case, or super flat, which in this case indicates about 1/8 of an inch. Now, there is only a rough correlation between the FF numbers and the straight edge methods. Roughly, an FF of 25 would indicate about the same difference as a quarter of an inch variation would. And an FF of 50 would correlate to a maximum variation of an 1/8 of an inch, which is what we need for the large format tiles. But it's important to remember that FF numbers don't include flatness along construction joints, blockouts, or at the edges of the slab. That's not where the measurements are taken. But a tile contractor can be expected to tile over construction joints or up to blockouts or on the edges of slabs. So there's a huge difference there. But perhaps the biggest difference between these two methodologies is the time difference in when this slab is measured. Because the ASTM test method for measuring that slab for flatness has to occur, as the little clock would indicate, within the first 72 hours of that slab being poured. Now, we all know that concrete changes volume. Now, it changes the most during those first during those first 72 hours. But the concrete is going to continue to change after that time. So while a floor might meet that FF of 50 or that theoretical 1/8 of an inch flatness at 72 hours, it may be weeks or months before the tile installer gets to that job site to install the tile, and taking into account construction joints and edges of slabs and everything else, it may be nowhere near that FF of 50 that was originally designed into the specifications. That all leads me to say that there are probably going to have to be some remediation methods in order to attain that proper flatness that we're looking for. Now, I'm going to go clockwise from the upper right-hand corner. What historically tile contractors have done is a patch coat or a skim coat. This is where he takes a straight edge, a level, a laser, whatever device he's using, and he marks that floor. He marks the high spots and the low spots. He'll try and grind down the high spots, and he'll try and fill in the low spots with a cement-based patching material to try and get him to that flatness that he's needed. Now, one of the methods that's available that often isn't done is to make the tile installer himself responsible for his own substrate. And the way we do that is to say, we want a conventional mortar bed installation. Now, there's a couple things that make it more difficult to execute. Number one, it's very labor intensive. That equates to it's more expensive. Number two, unfortunately, there are fewer and fewer contractors out there who are competent at a conventional mortar bed installation. We just don't do it much anymore. But from a design standpoint, the real problem has to do with the thickness of the installation. In a conventional mortar bed installation, the mortar bed has to be at least 1.25 inches thick. Then you've got about 1/4 of an inch of bonding material, give or take. Then you've got the thickness of the tile. By the time you're done, you're at about 2 inches. In order to make transitions to other flooring materials work, you have to recess the slab where that mortar bed installation is going. That's very seldom done these days, which leads us to the third method. And the third method is to allow us to use what they call a self-leveling underlayment in place of those other two methods. Now, the standard for self-leveling underlayment for the material is in 118.6, and it's also called flowable hydraulic cement underlayment. There's a reason for that. Self-leveling sounds like it does it by itself, but self-leveling really requires a competent installation team as well. And it can be used for flattening, and it can be also used to level a substrate. But it's a great product. And when we talk about the results, we have found that with self-leveling underlayment, we get an FF that's equivalent to about 80, as opposed to the 50 that we're looking for with the concrete division. So it's an excellent way to make sure that we're getting a flat substrate for our large format tiles that we're going to walk on. Now, the problem with this is that it really has to be an allowance. The beauty of this product is it can be used from 1/8 of an inch up to 2 inches, depending on how much is needed. But because of all of the things that we've talked about before, we sometimes don't know how much is going to be needed on any particular project. What I usually suggest is to allow the contractor to do 1/8 of an inch over the entire floor. If you don't need it, great, there should be money coming back. If you need more than that in some areas, at least you will have a way of determining what the initial cost was and figuring out what that additional cost might be without just taking a request for an add-on to the contract. Best practices for installing any type of finish should follow a process. And we've kind of outlined the step-by-step process that can be used for most flooring, but most importantly, ceramic, engaged tile, porcelain panels, and slabs. It starts with planning, which includes the specification, the materials, and any pre-construction communications between all of the parties involved. It's probably the most important step of all of these. We've already touched on surface preparation. It's what has to happen prior to the actual installation of the material. The next is the installation, and with tile, it's talking about the finished materials, the labor, the scheduling, etc. Then once it's installed, we have to grout it. What does that mean? Are there going to be metal trims? Are there going to be transition pieces? Are there protections for different types of finishes? And lastly, one of the things that I find that's often left out of this whole process is not just the final cleaning before takeover, but also instructions for the proper maintenance of that installation to the end user. How can he best maintain that floor for the lifetime of that product? So cleaning and care instruction becomes a big part of that continuing process. So good planning can help us avoid a lot of undesirable outcomes. Number one, using qualified labor makes a huge difference on any project. And I'll talk a little bit about that more here on the next slide. A cut and paste approach for specifying tile and stone installation does not work any longer. Each project should be a standalone specification because the technology may be different from one project to the next. What worked on the last project for just a 2x4 tile will not work on a glazed porcelain tile panel or slab on the next project. Use the ANSI specifications and Tile Council installation guidelines within your project documents to ensure a proper installation. And I'm going to go one step further here. One of the things that I've seen in a lot of specifications is a reference to F113. F113 is a direct bond thin set application where we're adhering directly to a substrate. And then somewhere else in the specifications, they talk about a waterproofing membrane or a crack isolation membrane, but they reference F113. Well, F113 does not include a waterproofing membrane or a crack isolation membrane. There are separate Tile Council methodologies for each of those. F122 is the waterproofing membrane installation on a thin set basis. F125 is the crack isolation installation on a thin set basis. You may have 5 or 6 different Tile Council recommended installation methods on one project. Those should be spelled out by location. In other words, in the shower, I need this particular Tile Council handbook. In the lobby, I need this particular Tile Council installation. On the second floor, it may change that specification methodology somewhat. So it needs to be very specific to the installation that's being done. And lastly, it's a good idea to contact the manufacturer of either the tile or the setting materials to make sure that the intended uses, design, and installation methods meet with their approval. I've seen a lot of litigation that would have been prevented had this kind of construction communication taken place. When we talk about qualified labor, here are some of the organizations that can help you find that qualified labor. There's the Advanced Certification for Tile Installers. There's the Ceramic Tile Education Foundation. There's this, I don't know, National Tile Contractors Association thing. That sounds a little shady. I'm just kidding, Jim. There's the Tile Contractors Association of America, and there's the Tile Council of North America. All of those organizations can help you define and find qualified installers for the particular type of project that you're doing. And I will assure you that if they meet one of or more of these criteria, your job will go that much smoother. Material handling comes into play and is an early stage planning process, and it really changes with glazed porcelain tile panels and slabs, because these things may or may not fit in an elevator. You know, the video you just watched shows, you know, that looks to be about a 5 foot by 8 or 5 foot by 9 porcelain panel, that the only way they could get it where they needed it was by a hoist and through an opening in the building. That may happen on every project. It's not as simple as carting up a case of tile up some steps anymore. It can be much more involved. And then the term material handling also talks about delivery, movement of, and storage of those materials. I will tell you that the initial investment in a glazed porcelain tile or panel or slab, the initial investment in the materials just to handle and install that is probably in the neighborhood of $10,000 to $15,000, because without that, they're going to have more damage that relates to that product than they normally would with other large format tiles. So we want to be all on the same page. Final pieces of the of the planning puzzle is the agreement of the materials and methods from everybody involved, which involves the manufacturer, the installation systems manufacturer, and the installing contractor. And by the way, most specifications that I read have language in it that talks about single source supply. However, honestly, I see it very seldom policed. But there's an advantage to making sure that's done. If you have an installation system from one manufacturer, it will provide you an enhanced warranty program that's relayable up to the end user. You know, if you have a grout from one manufacturer and a mortar from another manufacturer and a membrane from yet a third manufacturer, and then there's a problem on that project, first of all, you're going to get a lot of finger pointing. Well, it's not my product, it's the other guy's product. It didn't handle well. If it's one manufacturer, it's one phone call to make. Makes it easier to if there are difficulties. But the other thing that makes it more important is when that happens, when there's varied products in an installation system, you're only going to get a 1-year product warranty from any of those products. If you have a specific warranty package from one manufacturer, you're going to get at least a 5-year, more than likely a 10 or 15-year warranty. And in some cases, depending on the product selected, you could get up to a lifetime warranty. And there's no cost to that to anybody. It's transferable to the end unit, and it just makes sense to take advantage of that. And it's just a matter of ensuring that the single source supply requirements are met. During installation, this is the things that we should look for when you're on a job site and you're just watching them install tile. Number one, our standard here is ANSI A108.5, setting ceramic tile with dry set modified exterior grade plywood and improved dry set cement mortar. And one of the first things, excuse me, one of the first things you should look for is directional troweling. That's one of the things that's become important in our business. It helps us get the proper coverage that we need, because when they install tile with directional troweling, air is allowed to escape out the sides of those trowel marks and allows us to flatten that much more successfully. But in addition to that, the type of tools that are used can play a huge part in what kind of installation that we get. Now, in section 2.2, applying dry set cement mortar, it talks about the average contact area, and it's 80% except on exteriors and in shower or wet installations where the contact area shall be 95%. I might also add that the 95%, a specifier or an architect can specify 95% project wherever he feels it might be needed. It's just a part of the specifications at that point. But what I want to illustrate here is that proper tools and techniques can help achieve that much more successfully. For decades, the trowels that we used in our business were square notch trowels. Quarter by quarter, quarter by 3/8, half by half, etc. But as we leaped into the technology of these larger and larger tile formats, we found that they weren't getting the coverage that we should based on those standards. So new trowels were developed. They're sometimes called zipper trowels, sometimes called European trowels, but what they all have in common is that they kind of allow the mortar to roll over as it's being pressed in and gives you a better coverage. And this photograph on the left is an example of that. On the left-hand side, we have a traditional square notch trowel that's been, where tile's been pressed. And on the right side, we have one of those zipper or European trowels where it's been pressed. And as you can see, the coverage on those two things, just by changing the trowel alone, is vastly different and will get you to that standard 80% that we're looking for, unless it's in a wet area where it needs to be 95%. After installation is when most of these installation inspections take place. And it's important to understand that when we talk about inspections, we're not talking about getting on down on our hands and knees with a magnifying glass. And yes, I've seen some homeowners do that. But when we talk about inspections, what we're typically talking about is at a distance from 36 inches for a wall inspection, in other words, 3 feet away, and at a distance of 50 inches or 4 foot, 4 foot 2 inches if it's a floor installation, because anything that's not visible at that kind of spacing is considered to be acceptable. Now, I talked about some of these are very objective standards and some of these are kind of subjective standards. Well, here's most of the subjective, and it has to do with cuts. The cuts, the installation requirements are to center and balance areas of tile if possible. An excessive amount of cuts shall not be made. No cuts, usually smaller than a half-size tile, should be made. All cuts on the outer edges of the field. I've seen all of these not done, and yet the installation is fine. It's kind of what I mean by subjective. It's in the eye of the beholder. There's no measurable way to determine if these cuts are successful. It's just whatever the eye sees. And as you can see on the photograph on the right, I'd have a problem with that one, okay? If we do have cuts, those edges are supposed to be smooth so that it doesn't have any jagged or flaked edges. It goes on maintaining the height of tile work, etc. These are all guidelines. These are not something that it's really, able to be measured in terms of inches or millimeters. But again, it's in the eye of the beholder. But some things we can measure, and lippage is one of those things. This is in A108.02 general requirement. It's a lippage chart, and it has lippage standards according to the type of tile it is. And as you can see, depending on whether it's a paver and the width joint, it can be a 1/16 of an inch or a 32nd of an inch. And to give you a frame of reference, a 32nd of an inch is about the thickness of a credit card. So we're talking about something very, very small. And most people refer to this when they're talking about excess lippage, but I will caution you that this is a starting point. 4.3.7 also makes reference to the allowable thickness of the tile modules and the allowable warpage of the tile modules. Those two things may be added to that starting lippage amount to come up with a lippage that's appropriate for that particular tile. The other thing that comes into account is the spacing or the separation of the tiles, how close they are together, the angle of natural or manufactured light, and a caution that highly reflective surfaces have a tendency to accentuate lippage anyway. And when we talk about lippage, typically we're talking about floor tile, but I want to inform you that it can also happen on wall tile. Here's a case where we've got severe lippage. Now, the primary culprit in this particular installation is not the tile or the installer, I don't believe, but it's the lighting. Wall wash lighting will accentuate any lippage issues on a wall. If that lighting had been pulled out 2 or 3 feet, it would not be nearly as noticeable. Now, I don't know what the standards were for warpage or thickness or anything else of that particular tile, but I will tell you that if that's a thin set application, which it probably is, then it's probably not due to workmanship, but the material itself and the way the lighting is exposed. So a lot of things come into play here. Grout joints. Grout joints are another area that we had to kind of reevaluate with the new technology of large tiles, because at the same time these tiles were getting larger and larger, the grout joints were getting smaller and smaller. And we realized there's a time and a place where an installer cannot be expected to execute what's sometimes in specifications. So they had to come up with the definition of a minimum grout joint size. And that definition, according to ANSI 4.3.8, is 3 times the actual variation of facial dimensions of the tile supplied. Now, if that didn't clear it up, let me explain. It means you take the largest tile and the smallest tile on any particular project and you measure the difference. Let's say that that's a 1/16 of an inch. Then 3 times that variation is 3/16 of an inch. That's the smallest grout joint that installer should be expected to do with that tile. Now, the problem is we often don't know what that's going to be in the design process. My suggestion here is to ask the manufacturer. Many of them supply it with their tiles, but if they don't, ask the manufacturer, what's your recommended grout joint size for this particular tile? They will know what works best with their particular product. Don't go below that recommendation, or you may be in violation of that standard, which means if there were lippage issues later, it may be a design issue as opposed to an installation issue. 4.3.8.1 has to do with specific running bond or brick joint patterns. And in this case, they're talking about, and this is with large format again, in this case, they're saying that a minimum of 1/8 of an inch wide joint is required for a running bond or brick joint pattern if you're using rectified tile that's been squared off. If it's a calibrated tile, which is everything else, you have to have a minimum of 3/16 inch wide grouts for that particular pattern. And that can be increased by the amount of warpage on the tiles that are being installed. So it may have to go a little bit higher than that, but that's the minimum that can be expected. And not just the grout joint size, but also the pattern has a difference here. If you're using a large format tile in a running bond or brick joint pattern, you can go no more than 1/3 of the way into the next tile with your tile joint. And the reason for that, it has to do primarily with pressed tiles, is that when tiles are pressed in a press, they're typically a little bit thicker at the middle than they are at the edges. The press isn't great enough to overcome that. So when you have a 50% offset pattern, you're at the high point of one tile, the middle, and the low point of the next 2 tiles, which is the ends. If we go no more than 1/3 of the way into that next tile, it minimizes that high to low offset and makes it a much more acceptable installation in terms of lippage and appearance. Movement joints. Movement joints are required over all construction, control, and expansion joints in the backing and where backing materials change or change direction, including change of planes. So first of all, let's talk about change of planes. Anything that abuts the tile work from moving is a change of plane. So if you've got a built-in desk area in a lobby, that's a change of plane. There should be a soft joint around that desk to allow tile to move. There should be a soft joint around the perimeter of that installation. Again, even slab on grades move somewhat, and that allows this movement to take place without doing any damage. So let's take a closer look at what that means. F3.7.2 is if you've got a situation where temperature changes more than 100 degrees Fahrenheit, and that's typically on an exterior, although sometimes it could be on an interior with a lot of glass exposure. But when that happens, you have to locate the movement joints in that exterior tile work, whether it's walls or floors, no more than 12 feet on center based on a 1/2 inch wide movement joint. In 3.7.3, if it's an environmentally controlled interior and the variation is not more than 20 degrees, that expands to 20 to 25 feet in each on center in each direction. So that if you've got a 50-foot by 50-foot lobby, somewhere in the middle should be a cross or an X identifying 4 specific quadrants, and between that should be a soft material allowing that tile work to move independently so that there's no excessive pressure put on any part of that tile installation. And F171 in the Tile Council Handbook does the best job of explaining these joints and how they're to be constructed. But the most important consideration, I think, is what kind of a joint is it? If it's an existing joint in the substrate, then it has to be resolved at that particular point. In other words, you can't determine where that joint's going to be. The substrate is already determined where it's going to be based on that opening in the material. That's where it was designed to move. So if we've got a construction joint, could be as simple as concrete pours on 2 different days. If we've got a construction joint in the substrate, then a soft joint has to come up all the way through that substrate as shown in that diagram on the right-hand side of the page. If we're just dealing with movement joints within the tile assembly itself, it gets much easier. There you have some latitude as to where they're placed, and it can be as easy as a bond breaker tape with some flexible urethane or silicone sealant. But regardless, it still needs to be done. And the ANSI standards and Tile Council Handbook both put the responsibility for designing movement joints on the designer and or architect involved. It's not the contractor's requirement to show you. Now, a good contractor, if they're not on the plans, will provide you a diagram where he's planning to put them, but it's actually the responsibility of the architect or designer to make sure those are done and included on plans. And it's especially important when you've got an intricate pattern of some kind. It needs to be considered during that pattern consideration. We covered a lot of ground. And I'm sure there are some questions on it. Jim, how'd we do?
Don't worry about me. I'm just back here sleeping. Sorry about that. All right, Mike, you did really good. And I appreciate it. I want to get to our questions. We have a few questions here, and
okay.
I think you'll be able to answer these. So the first one came early. And it says, have manufacturers started adding the slip usage? I think that's DCOF. This person seems to get confused and looks when confused looks when he mentions it. From do manufacturers put that in?
It depends on the manufacturer itself. Some of the manufacturers have jumped on this. Some of them are a little slower about it. I'm not surprised. Remember, this was just introduced in February of last year, and the manufacturers, because of their manufacturing processes and quite frankly, the liability that goes along with suggesting this, are running a massive amount of tests to make sure what they're recommending the product for meets that requirement. If you have a project where you can't find, let's say it's an oil or grease situation, that's a fairly common one. My suggestion would be to talk to your professional, competent sales representative and ask them, has your company designated any tiles in this classification? And if so, which ones are we talking about?
Great. So the next question is on final cleanup, and it says final cleanup details are rarely spelled out. Most often they are not.
Right.
There's argument over who is responsible for delivering the tile work clean and free of any residue or residual dirt. Please comment.
I think it's the tile installer's responsibility to do the initial cleanup, but it's also the general contractor's responsibility to make sure it's protected from the other trades. So it's a kind of dual responsibility here. But the bottom line is, who ends up being, put to the test more often than not is the tile installer, which sometimes isn't fair. If they follow the guidelines, and as the NTCA reference manual suggests, I would send a letter to the owner and general contractor saying this freshly installed tile needs to be protected. That way, that kind of shifts that burden back to those folks.
Great. The next comment is by one of our attendees saying that wall wash lighting is addressed in the NTCA reference manual. And I do want you to know there's a whole section with causes, corrections. There's even tips. There's a sample letter for tile contractors to send to the GCs and architects explaining how that needs to be taken care of. So I wanted everyone to know. That was great. Thank you.
You bet.
We got, here's one, regarding cuts and what is acceptable with workmanship. If a room or wall is laid out properly, there should not be an issue with this. So we have a comment, and do you have anything to say on that, Mike?
I agree, but job site conditions can sometimes make cuts necessary where you typically wouldn't put them. You know, it's hard to develop hard and fast rules for every situation that they might encounter on the job site. It's great recommendations, though.
It's a great idea, but it is hard. Recommendations are hard to follow for everything. So,
right.
The next one is, please discuss how you explain to specifiers how manufacturers' recommendations are there to ensure success. Disregarding them puts ownership on specifier.
I see this most often in that single source requirement that's very seldom held. But the fact of the matter is that the way I get it across most points now to an architect in particular is by saying, what kind of a warranty are you looking for? Because if it's anything more than 1 year, you're going to have a system warranty to accomplish that. And a system warranty can come from many manufacturers. It's not, you know, every major manufacturer, you know, offers these extended warranties, but it's implanting that idea that if you want an enhanced warranty, it comes with certain requirements, which is an entire system as opposed to piecemeal.
Great. I just wanted to make a comment about the running bond, like a 12 by 24 tile, and you said you need to use 33% offset instead of 50%. But it is important to know that some tiles are flat, and if you do a mock-up, if you can show your customer, yes, it works or it doesn't work by doing a mock-up. I personally have about 250 square feet in my dining and kitchen area, and I wanted it to be 50% if possible, and it was very flat tile and it looks great. It's just that it's hard to get that flat tile with the process of going through a kiln and heating and everything. So I don't want people to think you can't use 50%, but you really should do a mock-up so the end user can see what they're getting.
You're exactly right, Jim. You know, we had the standards had to be developed, but there are exceptions to everything. And there are a lot of tiles that can be laid in that manner perfectly well. But in order to protect everybody in that situation, the mock-up puts the acceptance of that product and installation on the owner, as opposed to you know, having somebody take that liability, either the general contractor or the tile installer taking that liability himself. You're exactly right.
The liability part is the important part, and making sure you do that mock-up. So that's great.
Right.
We have another ask for maybe a little comment on RFIs, and especially for movement joints. And maybe you can explain that and talk about that a little bit.
Okay. The Tile Council and ANSI standards make it perfectly clear that it's up to the designer of the floor to indicate where those movement joints are going to go. That's very seldom done. In that case, the competent commercial contractors have gotten used to providing that as an added benefit of their expertise. That doesn't negate the responsibility of the designer and architect having supposed to have done it up front. But as long as it's done according to the standards that 12 foot on center, 20 to 25 foot on center, as long as it takes those considerations into account, it really doesn't matter who does it as long as they're done.
Okay. So here's a question. Around the 5th or 6th slide, there was a picture of some sort of testing device with 2 probes. Can you explain what that is? Can you explain what that is, Mike?
I don't know the name of the machine, but it's for more specific measurements of when you're trying to achieve a super flat surface. And it's most commonly used in warehouses, believe it or not, when they've got mechanical devices that pick orders that are running up and down these aisles. They may have to have a super flat floor for that to work properly, to get the right angle into the racks with the forks of those things. And it's just a methodology for being more precise in that measurement.
So if our attendee wanted to know more about that, would you be able to, if they contacted you directly, be able to maybe find that information or
I
help
sure
them?
could.
Okay.
Yes.
Larry, if you want to reach out to me, send me an email. I'll connect you with Mike and we'll get you an answer. Thank you.
You bet.
All right. So question on soft joints. What about soft joints for vertical corners in bathrooms? Very, very often I see cracked grouts in joints.
And it's one of the things that continues to baffle me, Jim. That is a change of plane. We know that those walls in a shower are going to move at different relationships. It's very well defined in EJ 171 as a change of plane. It should be a soft joint from the very beginning of the installation. It's often not. It's just an overlook. It's just, well, gee, I've always done it this way kind of installation.
And that is outlined in the TCNA handbook, correct?
Yes, it is.
Yep, definitely. All right. Can you do a 1/16 of an inch grout joint for large tile on the floor?
If it meets certain parameters, yes. That's, but I don't know of any tiles that are that precise.
Yeah,
I wouldn't recommend it. I wouldn't recommend it.
I think
It's just
they would have to be a rectified tile and they would have to be perfect, right?
yeah, they'd have to. Everything would have to be perfect. The substrate flatness. I certainly wouldn't recommend it.
All right. How about here's one. Ragged cuts are often seen. Does best practices call for them to be smooth with a sanding block?
Yes.
Right.
They're to take any flaked or jagged edges off of that edge. Now, in a lot of cases, that can be accomplished by putting that edge next to a grout joint as opposed to exposed. But yes, I'm thinking on corners in particular. But yeah, it calls for those things to be smoothed.
I agree. All right, Mike, thank you. What a great presentation with lots of information that everyone can use. Architects, designers, contractors, showroom personnel. It's great information and I wish we could get it out to more, but we'll keep fighting that fight and get it out there. I want to thank everyone for attending. We had great attendance today and thank you. Our next program is October 17th and invites will be coming out. So thanks everyone. Thanks Mike. Have a great day and we'll talk soon. Bye-bye.
It was my pleasure, Jim.
All right.
Take care,
bye
my
everyone.
friend.